Now let's talk about graphing logarithmic functions. Since logarithmic functions are inverse functions of exponential functions, then the graph of the logarithmic function and the graph of the exponential function should be symmetric to the line y equals x. And remember what we had when b was greater than 0, our exponential function looked like this. So by symmetry, log base b of x should be equal to this. Likewise, when b was less than 1 but greater than 0, this dashed line was our exponential function. If I selected across the y equals x line, this is going to be my log function. Just some things to note here. For my log function, the domain here is 0 to infinity, all the positive real numbers. Again, that was equal to the range of the exponential. The range is all real numbers. Again, that was equal to the domain of the exponential. No y-intercept, but we do have an x-intercept of 1, 0. This one is increasing as we go from left to right, whereas this is decreasing. They both have a vertical asymptote of x equals 0. They are 1 to 1 because they pass the horizontal line test. And my anchor points are going to be negative 1, 1 over b, 1, 0, and b, 1. So notice those are the same anchor points for my exponential, just with the x and y coordinates reversed. So the way we're going to build our log functions is, if we need a graph of a logarithmic function base b, we can build a table of the points b to the x. So x and then b to the x. And then we're going to just switch the x and y values, get a table for the logarithmic functions. So let's head to problem number 20. And we want to graph the logarithmic functions y equals log base 3 of x. Rewrite the exponential form and select values for y. Okay? So in other words, we're going to pick in numbers. So if I write this in exponential form, this would be 3 to the y equals x. And now I'm going to just switch x and y here. So I'm going to pick values for x. I'm going to pick values for y. I'm going to find out what x is. So I'm going to pick negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now, here's a quick way you can generate this table. If I go into my table, let me see if this will let me do this. So we're going to go to 3, caret key, and if I hit my variable key, if I keep hitting it, no, it's not going to let me cycle down the y, so I'm going to just use A here. See what this does. We're going to start at negative 3, and we're just going to click OK. Oh, did not like that. Okay, so that doesn't work. So let me go back to the table. I'm just going to change it to an x. Just realize I've got them backwards here. Okay, so there's our numbers. 1 over 27, 1 over 9, 1/3, and I can arrow down to get the rest of them. 1, 3, 9, and 27. So I'm just doing the exponential, but just going ahead and automatically reversing it. Now, when you're doing this in Alex, you're going to have to plot several points. So we do plot a point figure, and sometimes it's going to it might ask you to plot 3 or 4 points. And then also an asymptote. Remember, this has an asymptote of x equals 0. So I'm just going to label that down here, vertical asymptote. X equals 0. Let's plot some of these points. So I'm going to do these ones over here. So this is 1, 3. 3, 1, 9, 2, 27, 3. So that gives me this part here. And let's get this part over here. So this is 1/3, -1. 1/9, -2. 127, -3. So it gets really close to this axis. So my graph's going to look like that. And again, these are just kind of reiterating the properties that we've talked about some before. Kind of comparisons between the exponential versus the logarithmic functions when b is greater than 1. Again, notice that the domain and range has been switched around when we do this comparison between my exponential and logarithmic functions. Vertical, horizontal asymptote, because again, x and y have switched around, the point they pass through is switched around. Alright, so let's go ahead and take a look at some applications. So this first one here, we want to use the formula pH equals negative log of H positive. The variable pH represents the level of acidity or alkaline of a liquid on a pH scale, and H positive is the concentration of ions in the solution. So I want to determine the value of pH in moles per liter for the following liquids given their pH. Express your answers in scientific notation with 3 significant digits. Okay, so we're trying to do this. They give us the pH. So we're going to set that log equal to that to that positive 2.3. Now, in order to be able to figure out the argument I'm going to have to rewrite this in exponential form. Before I do that, I need to have the log by itself. So I'm going to divide both sides by -1. And remember, since there's no base written here, we're using the common log, so my base is 10. So you may just want to kind of write the 10 in there just to remind yourself. So that's my base. So my argument, which is H positive, equals my base and my exponents to the -2.3. So I just need to evaluate that on my calculator. So let me get out of this. I'm going to do 10 caret key -2.3, and I get 0.005 blah 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 blah. Now the problem is they told you on your calculator to express your answers in scientific notation with 3 significant digits. So here's how you get your answer in scientific notation. Go to your mode key, and you want to arrow down until you have the flashing cursor over SCI and hit enter. And then do second quit. If I hit enter again, then it's going to put in scientific notation. So they want to round to 3 significant digits, so it'd be 5.01 times 10 to -3. Let's try part B here for number 20. So now we're doing 6.2. So again, we're going to use our equation they gave us. Before I can convert to exponential form, I need to get the negative over the other side, so I'm going to divide by -1. And just keep in mind here, my base here is 10, so I'm just thinking about there being a 10 here. I'm going to rewrite that as 10 to the power of -6.2 has to be equal to my H positive. Now, the good news, my calculator is already in scientific notation. So I should be able to pop it in. It's going to give me the answer. So that'd be 6.31 times 10 to the negative 7. In the moles per liter. So we're going to be doing a lot more practice with converting between one form to the other. Because if here, I need to get the argument. And the only way, if I'm solving for the argument, I'm going to have to change that log into an exponential. Similarly, if I have an exponential, and I'm trying to get to the power to solve for the power, I'm going to have to convert to a log form.